Now next problem is also an easy problem. It may look a bit of long problem and a difficult problem, but in reality it is not, provided you know the concepts of cube root of unity again. We are given with an expression 1 plus x square power n is equal to a naught plus a1x up to a2n x power 2n, and we need to prove that a naught plus a3 plus a6 is equal to a1 plus a4 plus a7 up till the last term is equal to a2 plus a5 plus a8 up till the last term is equal to 3 power n minus 1. So what we need to do is, since we are having the term of 1 plus x square, let us put x equals omega. So this, the left hand side becomes 0 is equal to a naught plus a1 omega plus a2 omega square plus a3 omega cube plus a4 omega power 4 up till a2n omega power 2n. We have put x equals omega because here we need to prove a naught plus a3 plus a6, all these terms coming together, a1 plus a4 plus a7 terms coming together, and a2 plus a5 plus a8, these terms are coming together, and in all these three brackets there is one common thing: the terms are in a gap of 3, that is a1 then a4 then a7, there is a gap of 3, a2 plus a5 plus a8 again a gap of 3, and a naught a3 a6 again a gap of 3. And we know that we can create the terms with gap of 3 if we put x equals omega, because omega cube is equal to 1. So we get a naught plus a3. Again we will have a term a6 omega power 6, and omega power 6 is again equal to 1 because omega raised to the power any multiple of 3 is 1. So this again becomes equal to 1. So a naught a3 then a6. Similarly omega power 4 is omega, so we can get the terms of omega times a1 plus a4, and hence the terms which we are seeing over here. So remember one thing, if in any problem you see the terms in a gap of 3, just try to put x equals omega. So this becomes 0 is equal to a naught plus a3 plus a6 plus omega times a1 plus a4 over here, and definitely the next term will be a7 up till the last term, plus omega square times, this is a2, definitely there will be a term over here a5 into omega power 5, and we know that omega power 5 is equal to omega cube into omega square, and omega cube is equal to 1, so omega power 5 is equal to omega square. So this becomes omega square times a2 from here, a5 from here, and similarly till the last term, and the value is equal to 0. So let us take this thing as a, the value of this thing as b, and the value of this thing as capital C. We need to prove that capital A is equal to capital B is equal to capital C, and the value is 3 power n minus 1 as asked in the problem. So we have A plus B omega plus C omega square is equal to 0, and also we know that omega square plus omega plus 1 is equal to 0, since omega is a root of quadratic x square plus x plus 1 equals 0. Omega is a root. So in comparing these two equations, we get A is equal to B is equal to C. Now our original expression was x square plus x plus 1 whole power n is equal to a naught plus a1x plus a2x square up till a2n x power 2n. On putting x equals 1, we get 3 power n is equal to a naught plus a1 plus a2 up till a2n, which is equal to a naught plus a3 plus a6 plus A1 plus A4 plus A7 plus A2 plus A5 plus A8. In this way, we have written this entire sum as a sum of three different summations, since we required the values of this, this and this, and we know that this is capital A, this is capital B and this is capital C, but we know that capital A is equal to capital B is equal to capital C. So this entire sum is equal to 3 times capital A, and we know that this sum is equal to 3 power n because we put x equals 1 over here. So we get 3A is equal to 3 power n. So A is equal to 3 power n minus 1 is equal to B is equal to C, since we proved A equals B equals C. Hence we have got A0 plus A3 plus A6 up to the last term is equal to A1 plus A4 plus A7 up to the last term is equal to A2 plus A5 plus A8 up till the last term. These all three sums are equal and each are having the value of 3 power n minus 1, which was the desired result to be proved.